Hello students, how are you all? So let's discuss work energy theorem. Now this is one of the most basic and fundamental theorems in mechanics. So what does it say? It says that the total work done by all the forces on a system is equal to the change in kinetic energy of the system. Yes. So work done by all the forces is equal to delta Ke. Now delta here represents change. So delta Ke means change in kinetic energy, which is measured by final kinetic energy Kef minus initial kinetic energy. So this is the mathematical formulation of this work energy theorem. W all forces, which means the work done by all the forces is equal to change in kinetic energy, which is equal to final kinetic energy minus initial kinetic energy. Now one very important thing here is that the work done by all the forces. Yes, in the statement, we have seen that it says work done by all the forces. When I say all the forces, this means that it includes everything. Forces acting inside the system, which are known as internal forces, as well as the forces which are acting from outside the system, which are known as external forces. So it includes external as well as internal forces. Okay. Now, using this, let us solve a very simple problem. The problem goes like this. A particle of mass 2 kg moves along the x-axis such that x coordinate of the particle is given by x is equal to 2t plus 3t square. So x here is given as a function of time. Everything here is given in SI units. We have to find out the work done by all the forces on the particle in the time interval. Time interval is given to us, t is equal to 1 second to t is equal to 3 seconds. So how do we go about it? Yes. So let's start solving the problem. We are going to use work energy theorem here. Yes. Hence, we need the initial and final kinetic energies. Yes. Okay. Now, for that, we need the initial and final velocities as well. So how do we find out the initial and final velocities? This is very simple, because we already have the x coordinate of the particle as a function of time. Okay? So all we have to do is simply differentiate that x coordinate. X को differentiate करके आपको याद होगा, when we differentiate x, that gives us velocity as a function of time. So let's differentiate that x, that give the function that was given in the question, and derive the velocity as a function of time. So velocity is equal to dx upon dt. So d by dt of this x was given in the problem 2t plus 3t square. So let us differentiate this. Differentiate this term separately, differentiate this term separately. This will give you 2 and this will give you 60. I'm not going into the details of this. This is basic differentiation. You must be knowing all that. If not, let's do this. Okay. So 2t, the first term, differentiation becomes 2. In the second term, there is 3t square. 3 is a constant. It gets out. D by dt of like this 3t square. So 3 gets out. It's a constant. Bach gaya andar t square. So we get this. This becomes 2t. So 3 into 2t. So we have 60. So that's what's written here. Yes. So we have obtained our velocity as a function of time, which is equal to 2 plus 60. Now the question becomes very simple. We simply have to substitute the value of time here. So to get the final velocity, that is at t is equal to 3 seconds, we just substitute time here. T is equal to 3, so we get velocity is equal to 20. And in the same manner, we get initial velocity. That means that t is equal to 1. We put t is equal to 1 in this expression. We get velocity initial is equal to 8. Now, work done by all the forces on this particle is equal to delta K, which is equal to change in kinetic energy, final kinetic energy minus initial kinetic energy. Kinetic energy is half mv square. Yes, you know that. So half mass final velocity square minus half mass initial velocity square. So solving this, you'll get the answer as 336. As everything was in SI, the answer will also be in SI. 336 joule will be your answer. Thank you and have a nice day.